Good morning, students. Today we continue our lecture on carboxylic acid. This lecture is presented by me, Pranit Ghatak, your chemistry teacher. So, let's begin. In previous classes, we have already been discussing the IUPAC nomenclature of carboxylic acid. In today's class, we are going to discuss about the preparation of carboxylic acid. There are 7 to 8 methods to preparation of carboxylic acid. Okay, but the main thing is, as you know earlier, that carboxylic acid is one of the most oxidized state of hydrocarbons. That is why if we oxidize certain things, then we will get the carboxylic acid. Okay, so it can be happen when we oxidize. Okay, just do one thing. Okay, we know the sequence, that is alkane, then alcohol, then aldehyde or ketone, then acid. Okay, so this is the oxidation series. Okay, what happens when we oxidize alkane, then it gives alcohol. If we oxidize alcohol, then it gives aldehyde or ketone. If we oxidize aldehyde or ketone, it will give acid. Okay, but in certain cases, if we use strong oxidizing agent, then alkane can also give acid, alcohol can also give acid, and aldehyde or ketone it can give acid for any oxidizing agent, because only one step is needed. Okay, for alkane we need high strong oxidizing agent. Here for this case, for alkane to acid we need highly strong oxidizing agent, because this is a 3-step process. Okay, but for alcohol we need also a highly oxidizing agent, because it is a 2-step oxidizing process. But for aldehyde and ketone it is a 1-step process, so we may not require the strong oxidizing agent. It can give acid from a aldehyde or ketone using a weak oxidizing agent as well. Okay, so by this reaction, that is from, if we oxidize alkane we get acid, if we oxidize alcohol we will get acid, if we oxidize aldehyde ketone we will also get acid. So this is the mainly 3 reactions that we are gonna talk about, and some other reactions as well, as when we use RCN, that is from cyanide, alkyl cyanide to acid, or even acid amide or amide, RCH2 to form acid. Okay, so to prepare it acid amide, to prepare it acid from amide. Okay, so there are also certain reactions as well, mainly 4 and 5, as well as some hydrolysis reactions. Almost 6 to 7 reactions or 7 to 8 reactions are there in to prepare the carboxylic acid. Okay, so let's begin. Here you can see this is alcohol. This is carboxylic acid preparation from primary alcohol or aldehydes. Here you can see this is a primary alcohol. From this primary alcohol we can easily oxidize when we need. I have already been saying that the alcohol, from alcohol to produce the acid, it is a 2-step reaction, so we will need a strong oxidizing agent, that is alkaline KMnO4 or Jones reagent. These both are strong oxidizing agent. While we use strong oxidizing agent, we will get acid from primary alcohol. Okay, similarly in case of, this is a aldehyde, that is acetaldehyde. Okay, acetaldehyde also already as aldehyde, and we know from aldehyde or ketone to acid, this is only 1-step reaction. Okay, only 1-step oxidation, so we may not need a strong oxidizing agent. Okay, that is why we are using a tolerance reagent. Tolerance reagent is not a strong oxidizing agent like KMnO4 or K2CH2O7 or Na2CH2O7. So while we oxidize alkane or alcohol, we need strong oxidizing agent, but while to prepare acid from aldehyde ketone we use a mild oxidizing agent like tolerance reagent. Okay, here the tolerance reagent is used to prepare to oxidize aldehyde and make it to a acid. Okay, that is for here acetaldehyde to carboxylic acid, that is acetic acid. Okay, so let's move to the next point, that is here, as I have earlier stated that this is a alkane, mainly this is a alkane product. Okay, this is toluene. Okay, and this is also alkane product. Here where we use, where to oxidize the alkane to prepare acid, we have to use a strong oxidizing agent. Okay, that is why we are using KMnO4, and it will eventually give the acid part. Okay, so this is toluene. Toluene will give the benzoic acid, and similarly this product will also give, this compound will also give the benzoic acid as well. Okay, so but to oxidize this alkane parts or benzoic alkane parts, benzyl alkane parts, we need to give the strong oxidizing agent. Remember, for alkane and for alcohols we need strong oxidizing agent. Other than that, we do not need strong oxidizing agent for aldehyde and ketones, to oxidize aldehyde or ketones. Okay, so let's move to the next point, that is RCN. Okay, so carboxylate is preparation from nitriles and amides. Okay, so for sorry about that. Okay, to prepare carboxylic acid, from alkyl cyanide, we have to use acid. Okay, if we use for alkyl, to prepare the carboxylic acid, from alkyl cyanide, we have to use any acid, any mineral acid, H3 plus. Okay, if we use any mineral acid, it will give a carboxylic acid. If we use any mineral acid H3 plus on RCN, it will give RCOOH. Okay, on the similar note, if any acid amide is there, RCONH2 is there. Okay, if we give this H3 plus, it will also give acid, it will also give RCOOH. Okay, so whatever the reaction is, if that is alkyl cyanide, that is RCN, or it is RCONH2, that is alkyl cyanide or alkyl acid amide or acid amide, both the things, while reacting with H3O plus, that is mineral acid, it will give carboxylic acid, that is RCOOH. Okay, while in the next thing, we know that while we discussing about the haloalkanes, then if we use the Gigner reagent, that is RMGX, with carbon dioxide as CO2. Okay, then it will give a acid RCOOH. Okay, while reacting with CO2, it will give acid, that is RCOOH. Okay, in the medium of diether. Remember, any Gigner reagent has to react in the medium of diether. So Gigner reagent, while reacting with CO2, it will give acid RCOOH. Okay, and the last point, actually, to prepare the carboxylic, not the last, this is the second last point of preparation of carboxylic acid, that is from acid halide. While we use RCOCl, that is acid chloride or acid halide, if it is Cl, then it is acid chloride. If it is iodine, then it will be acid iodide. RCOCl means acid chloride. Okay, while we use acid chloride, it will, with if you hydrate it with water, it will give acid. Okay, and similarly, in case of anhydride part, that is acidic anhydride or benzoic anhydride, any anhydride part, while we hydrate it like acid chloride, it will also give acid. Okay, so remember, for any acid derivative, that is acid halide or acid anhydride, if you hydrate it with water or solvate it, then it will give acid. Any acid derivative part, while reacting with water, it will give acid. That can be from acid chloride or acid anhydride. Okay, acid anhydride or acid chloride, both of them give acid while reacting with water. Okay, and the last reaction is the hydrolysis reaction. Carboxylic acid can be formed also from ester, that is, we know carboxylic acid, or we know this is a ester, Okay, while reacting with water and base, or water or acid, it will give, we know water like HOH, right? Okay, so what happen if we use water or base, or water or acid, it will, sorry, it will give a product like this, RCOOH, and from here it will give ROH. Okay, so it will be a acid and it will be a alcohol. Okay, so like that was, while decomposition of ester by water in acid medium or base medium, remember the hydrolysis can be occur in two ways. It can be in acid medium or it can be in basic medium, although the pathways are different. Okay, but the end product is same. So esterification, or sorry, the hydrolysis of ester can also be done in acid medium and base medium. So but the water should be there. Okay, so while we use water to hydrolyze ester, it will give acid and alcohol. Okay, so all of these 7 to 8 reactions can be, we can do to prepare carboxylic acid. I hope you have understood this part very well. If you get any kind of doubt, you can ask me in the comment section below. Okay, so that's it for now. Thank you very much.